Hello, this is Scholar Strive doing some math today. In geometry, we'll be looking at surface area of prisms and cylinders. A prism is a polyhedron with two congruent faces called bases that lie in parallel planes. So here's an example of, so we have two triangles that are hopefully the same, and then we just connect the dots here, and we got a triangular prism. The lateral faces are all the faces that are not the bases. Lateral faces of a prism are always rectangles. So if you ever have a prism, it's always a rectangle. Lateral face. Lateral area. Well, lateral edges is where the lateral faces meet. So if I'm using the triangle again, these yellow lines here would be lateral edges, not the triangular bits. Lateral areas, since they're rectangles, you just add up the areas of all the rectangles. The base area is whatever the area of that shape is. If it's a triangle, it's 1/2 base times height. If it's a rectangle, base times height, and so on. Surface area. Usually we denote it as SA is equal to the area of both bases plus all the area of the lateral faces. And we're going to go ahead and skip a lot of this. Well, actually, okay, never mind. A right prism is basically a prism kind of standing up at a right angle. So right angle here. And oblique prism is something like this. It's kind of slanted. Oh, actually, that's not slanted. Something like this. Yeah, can't draw it right, but just think of a box and you kind of like squish it and make it slanted to the side there. The surface area for any prism is the total base area added to the total lateral area. So there's this formula, but I tend to use these two formulas on the bottom here. But let's take a look at this formula. So surface area is equal to 2 times, so think of big B as the base. There's two bases. So since there's like, so for example, if I had, like, say, a cylinder, if I drew it correctly, we would have two bases and area of a circle. Since we have two, we have to add the areas of two circles. And then we would add the area of the side there. Let's say we have, let's go with the triangular prism again. We would find the area of the two triangles, add them together, or find the area of one triangle, and multiply by 2, and then we would add the areas of the rest. A cylinder, well, I think we already went over a cylinder, but it's like a can. The bases are circles. A right cylinder is a cylinder standing up. Oblique is a slanted cylinder. The lateral area, so since we have that curve going on, so we would find the areas of the circle. Area of the circle is pi r squared, but this piece here is 2 pi r times height. Surface area of a cylinder, again, same formula here, 2b plus LA, or lateral area, 2 times the base plus the lateral area. So this formula here, pi r squared represents the area of a circle. There's 2 of them. And then the area of the lateral area is 2 pi r h. So let's do some examples here. Alright, example 1. Find the surface area of the right prism. Note that the bases are equilateral. Find the area of the base. Oh, okay, so we're trying to find the surface area of this whole object. So we would need to find, we need to find the area of the base. And luckily we have this formula for us. So 6 squared times the square root of 3 divided by 4 is 36 divided by 4 times the square root of 3, and then I'm going to leave it as 9 times the square root of 3. So that is the area of my base. So I'm going to call this capital B. Okay, my lateral area is all the other sides. So let me take a look here. We have this side here, the red side. And that's just a 6 by 8 rectangle. So that's 48. Okay, and then we have the other side. Green rectangle, which is a 6 by, is that a 6 by 8 as well? That's 6, so that's 6. Oh, I'm confusing myself. There we go. So if this is 8, then that is 8. If that's 6, that's 6. Okay, still 6 by 8. So that's 48. And the bottom is also a 6 by 8. So 48 times 3, or 48 plus 48 plus 48, is 144. Okay, now to find the surface area, we're just going to do surface area is 2 times the base area plus our lateral area. So 2 times 9 root 3 plus lateral area, which is 144. Use our calculator. Actually, So yeah, this will be 18 root 3 plus 144. Use our calculator. And our surface area will be 18 root 3 plus 144, 175.2 square units. Alright, let's do another example. Find the surface area of a right rectangular prism box with height 5 foot, 11 foot, and 4 foot. So here we go. We got a right rectangular box here. Just means it's standing straight up. So that's 5, that's 4, that's 11. Okay, it's supposed to be standing up. At a right angle. There we go. So with a box, you can make any side your base. But basically what happens is we have two 11 by 5s. We have two 5 by 4s, two sides. And we have two bottom, like bottom and top. So that's 11 by 4. So this area is 55, this area is 20, and this area is 44. Okay, since there's two of them, 2 times 55 plus 2 times 20 plus 2 times 44 will give us our area. Or we could have added them together and then multiplied by 2. But we'll get 238 square feet. Alright, find the area of this right cylinder. So the area of a cylinder is, surface area is 2 times the area of the base plus 2 pi RH. Okay, so the area of the base is pi r squared, so 2 pi r squared plus 2 pi RH. Let's put it in our numbers. 2 pi r, which is 4 times 4, plus 2 pi times 4 times the height, which is 5. So I have 32 pi here. 16 times 2 is 32, plus 20. 4 times 5 is 20, times 2 is 40 pi. So this will equal 72 pi. Put it in our calculator. And we'll get about 226.2 square meters. Checkpoint 2. Find the surface area of a right cylinder with height 9 and a radius of 6. Alright, so we got a cylinder here with a radius of 6 and a height of 9. So surface area is 2 pi r squared plus 2 pi rh. So surface area is equal to 2 pi times 6 squared plus 2 pi r, which is 6, times height, which is 9. So I'm going to get 72 pi plus 108 pi, which is 180 pi. And you would use your calculator at this point, but I'm going to go ahead and say 180 pi square centimeters. Example 3. Find the surface area of the cylinder, or no, if the surface area of the cylinder is 198.8, find the height. Okay, so remember, surface area for a cylinder is 2 pi r squared plus 2 pi rh. So they tell us that this is 198.8 equals 2 pi r squared, which is 2.8 squared, plus 2 pi r, which is 2.8, times h, which is what we're looking for. So I'm going to get 198.8 equals... Okay, that first one's going to be 49.2352 plus 17.584h. Okay, I'm going to subtract this 49.2352 over the other side. Calculator. And I'll get about 149.5648 equals 17.584 times h. Since h is being multiplied by that, we're going to divide by that to both sides. And we're going to get h equals about 8.5 millimeters. All right, let's do that again. So they say, we'll find the radius of a right cylinder. Okay. Okay, so this, using the same formula, 168 equals 2 pi r squared plus, oh wait, 168 pi plus 2 pi r times h, which is 5. So luckily, everything shares a pi, so I can get rid of pi by dividing everything by pi. And this only works because everything has pi in it. So my equation now becomes 168 equals 2r squared plus 2 times r times 5, which is 10r. Okay, I'm going to go ahead and divide everything by 2, because everything has a factor of 2. So I'm going to get 84 equals r squared plus 5r. Okay, now if you don't remember this from algebra, this is a quadratic equation. And how we solve quadratic equations is either using this quadratic formula, or we can factor So I'm going to subtract 84 to both sides. So my equation is 0 equals r squared plus 5r minus 84. So we're looking factors of 84. So factors being they multiply to negative 84 and add up to 5. And that happens to be positive 12 and negative 7. 12 minus 7 is 5. 12 times 7 is 84. So we have two answers here. R is negative 12 or R is 7. Since we're dealing with actual length, the radius can't be negative 12. So the radius is 7. Hopefully this helped you out. Have a good day.